Hi guys, I made this little tutorial here for you to know how to do example 4 and 5. I really don't want to take that off the quiz. It's very important, but somehow we ran out of time today in class. So I just want to make sure that you know how to do this stuff so that you can still be successful on your quiz and also on your homework. So I just want to read this little box here with you. It says modeling dropped objects. So the picture here seemed kind of confusing. This is not actually what we're modeling over here. We're actually modeling someone standing on top of a building or at some height and just dropping an object straight down. So the equation that we have over here is actually modeling that scenario, not this scenario. It's just a tool they use there to show you how dropping an object might work with acceleration versus time and stuff like that. But this equation is the one we're going to use to model just dropping objects straight down, as is portrayed on the right hand side of the picture there. So to use the equation, you have to understand what the parts mean. So let's read this little prompt here. It says when an object is dropped its height h in feet, so this height h in feet, above the ground after t seconds, so this is time, t seconds, okay, can be modeled by this function where h sub 0 is the object's initial height. So h sub 0 is initial height. So the graph of h equals negative 16t squared plus 200 represents the height of an object dropped from an initial height of 200 feet, which is right here. That's what the picture is saying. So the initial height here was 200 feet. That's why they changed h sub 0 to 200 feet. So this model also assumes that the force of air resistance on the object is negligible and only works on Earth. So those details are okay for physics. It's a good physics application. We're not going to worry about those. We're just going to assume that the equation works. So let's work through solving one of these kind of questions. So first of all, just write down the equation, which I will give you on your quiz. 16t squared plus h sub 0. Then we're going to read the prompt and just see what each variable is in the prompt. So which number represents which variable. So let's read it together. It says, if you drop an object off the roof of an apartment building that is 240 feet tall, about how long will it take to hit the ground? Okay, so those are the three key pieces of information. So if you dropped an object off the roof of an apartment building that's 240 feet tall, so 240 feet tall is very similar to this scenario here, except you're on the roof. So this would be 240 feet up here somewhere. So 240 feet tall in this scenario would be our initial height, which is h sub 0. So initial height h sub 0 there. Then about how long will it take? So the question is asking how long will it take. So how long will it take is a time question. What is the time it will take? And then to hit the ground, so the equation gives us the height h after t seconds. Well, this is saying the height h when it hits the ground, how high is it above the ground after t seconds? Well, this is saying when it hits the ground. So how high above it the ground is it? It's not above the ground at all. It's on the ground. So that's 0. Okay? And so all you have to do is plug in those two numbers really and then solve the equation using the technique we learned right at the end of class today. So you're doing this. H is 0, the height above the ground after t seconds. T is what they're asking for. We don't know that. And then h sub 0 is 240 feet, my initial height. So just plugging those numbers in from our prompt. And then now we're just solving a simple quadratic equation involving square roots. So you take away 240 both sides. And you get negative 240 equals negative 16t squared. Divide by negative 16. And what you get if you do that, maybe you want to use your calculator or something, you get t squared equals positive 15. And then to get rid of the square, we do the inverse operation, which is take the square root. And now we said, remember, when you take the square root in an equation, you get plus minus root 15, which is approximately plus minus 3.87 seconds. But since it's time, we can't really have the negative option. So it's time, we can't have negative time. So the minus here doesn't work because of the application is actually saying that the solution must be positive because it's time. So that's that example 4. Finally, you'd get this answer. Root 15 is correct, but in real life, we would want to approximate it to something that we can actually speak about, like 3.87 seconds. All right, so let's look at another example, example 5. Similar thing. Again, you'd use this equation. H equals negative 16t squared plus h sub 0, where h is the height after 2 seconds, and h sub 0 is the initial height. So let's read this prompt and see what happens here. For a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. How long does it take the container to hit the ground? Okay, very, very similar, almost the exact same setup, just different numbers, a little bit of a different prompt. So you drop the container, or you drop the egg from a height of 50 feet. So that's my initial height, which is h sub 0. How long does it take? Again, it's a time question. What is the time to hit the ground? Again, my height after t seconds is 0 again. It's on the ground. How high am I after t seconds? I'm on the ground, which is 0 height. And so again, you do the same thing. 0 equals negative 16t squared plus h sub 0 in this case is 50. So again, subtract 50 both sides. Isolate the square like we did in class. So negative 50 is negative 16t squared. Divide by negative 16. And again, you can do this on your calculator. I'm just going to leave it this way and simplify, so you get 25 over 8 is t squared. And then to undo the square, you just take the square root on both sides. It's the inverse operation. And again, I'm not going to write plus minus here because this is a time question. So we don't really have negative time, so that's not an option. So we just have t is root 25 over 8. And we'll go ahead and approximate that. If you do that, you get about 1.76 seconds. All right. And so that's the solution. How long will it take to hit the ground if I drop an egg from 50 feet? Previous solution was how long will it take if I drop an object off an apartment building that's 240 feet tall, 3.87 seconds before it hits the ground. So those are two examples for the dropped object type of question. Again, please, I will give you this equation on your quiz, so don't have to worry about that. You will have the equation to work with. I hope this helps you guys when you're doing your homework and also on your quiz tomorrow, next class. Thank you.